Hello friends, this is Sandipan here. Welcome back to my YouTube channel. In the last video, we covered encapsulation and inheritance, two of the four main pillars of object-oriented programming. If you missed it, check that out first for a better understanding. Today, we will again dive deeper and explore the other two pillars of object-oriented programming, which are polymorphism and abstraction. Stick around till the end as we have some bonus topics at the end that will make the concepts more interesting. So, without any further ado, let's get started. So, let's start our exploration with polymorphism, the power of multiple forms. Polymorphism means the same thing can behave in different ways depending on the situation. It refers to the ability of an object to take multiple forms or behaviors in different situations. Assume that a person who have many qualities or relationships at the same time, such as a father at home, an employee at work, and a friend in social life. So here, the same person can have different behavior in different context. One person but many roles. That's polymorphism in real life. Polymorphism itself is made out of two words. Poly means many and morph means form. So having multiple forms. We can implement polymorphism in multiple ways such as operator overloading, class polymorphism, method overloading, and method overriding. So let's start with the simplest one, operator overloading. It means the same operator can do different jobs depending on what it's used with. More specifically, it performs various operations depending on the operands. For example, if we use the plus operator with numbers, it performs an arithmetic addition and adds up the numbers as the operands are numbers. The same operator can be used with strings. But here you see it performs concatenation on strings and joins them. So the plus operator behaves differently depending on the context or operands. Now that we have seen operator overloading, let's move on to the class polymorphism, which works a bit differently. Class polymorphism refers to the ability of different classes to have methods with the same name but implements the method differently. Let's see an example. Let's define a bird class having a speak method, a dog class which also has a speak method but with a different message. Now let's define a method which will take an object reference as argument and will call its speak method. Don't confuse it with inheritance. It's just the naming that looks related but no relationship made between them. Now let's create objects of both classes and call our animal speak method. So here, both bird and dog have a speak method, but each gives a different output. The animal speak function takes the object reference and calls its speak method. So the actual speak method that runs depends on which object is passed. So this is an example of class polymorphism, and since it's decided at program runtime, it's also called runtime polymorphism. Next, let's talk about method overloading. It occurs when a class contains multiple methods with the same name but having different types and numbers of arguments. This is actually an example of compile time polymorphism or static polymorphism because the method that will be executed is determined by the arguments at the time of compilation in the languages like Java or C++. Python does not directly support method overloading like some other languages, but we can mimic it using default arguments. Here's an example. Let's declare a calculator class and an add method. Now let's create an object of our calculator and perform some additions. Here, The add method in the calculator class can take 1, 2, or 3 arguments, providing multiple behaviors depending on the number of arguments passed to the function. That's method overloading. Even though Python handles this differently under the hood, this example demonstrates the concept of compile time polymorphism through method overloading. And the last in our list, method overriding. As we have already discussed in our previous video, in the inheritance part, you can revisit and check that out and let me know if you can find both the concepts in a single example. Finally, the last concept of the four main pillars of object-oriented programming is abstraction, hiding the complexity. Abstraction means showing only what's necessary and hiding the complex details. It helps to reduce code complexity and increase code reusability. Think about a car. When you drive a car, you only interact with essential controls like the steering wheel, accelerator, brakes. You don't need to understand the complex working of the engine, fuel injection, or braking mechanism. The internal details are hidden, and only the necessary functions are exposed for use. This is abstraction in real life. We can implement abstraction in Python using abstract base class ABC from the ABC module. To implement abstraction, we create an abstract class that contains one or more abstract methods. An abstract method is a method which is declared but does not have an implementation. The subclasses that inherits from that base class must override the abstract methods. So the concept of inheritance also takes place here. If you haven't watched my encapsulation and inheritance video yet, I highly recommend you to check that out first to have a better understanding about inheritance. So moving on, let's understand abstraction with an example. Let's consider a shape class where different shapes implements their own way of calculating the area. So first import ABC and abstract method from ABC module, then creating a shape class. Here shape is an abstract class with an abstract method area. We can use the pass keyword to skip the implementation of the method. Also, we have decorated the method area with abstract method decorator to mark it as an abstract method. Now let's declare two more classes inheriting the shape class. A circle class, a square class. Here, the circle and the square classes implement the area method inherited from the shape class. Also notice that the circle and square have their own init methods, while the shape class doesn't. And don't get confused here, it's by choice, but not a restriction. Abstract classes can define init method for common attributes, but the important thing here is abstract classes cannot be instantiated directly. Now we can create the circle and the square object and use the area method to calculate the area without bothering about the internal formula or implementation. Now here's a bonus concept for you, that is Pythonic duck typing. In Python, we don't always care about the object's class, but rather its expected behavior. This is called duck typing. Sounds confusing? There's a famous saying, if it works like a duck and quacks like a duck, it's probably a duck. So, if an object implements the required methods, Python lets it pass even if it doesn't belong to a particular class hierarchy. Let's understand it with an example. Let's define a duck class having a quack method and a person class also having a quack method and a method receiving the object and calling its quack method. And now let's create objects and see it in action. Here both duck and person have a quack method. So make it quack doesn't care about the object's type as long as the object can quack, means having the quack method. So this is the beauty of duck typing in Python. So in this video, we have covered the remaining part of the advanced object-oriented programming concepts in Python, which are polymorphism and how it helps us implement different behaviors, under which we have learned about operator overloading, class polymorphism, method overloading, method overriding, runtime and compile time polymorphism, abstraction to hide complexity and implementation details, and Pythonic duck typing as a bonus point. So that wraps up all about polymorphism and abstraction and the four main pillars of object-oriented programming. But if you missed any of the points out, make sure to rewatch it and it will definitely be clear. But if you still have any doubt, feel free to comment down below. Hope you find this video helpful. If so, give a thumbs up, share the video with your friends, and if you haven't subscribed yet, subscribe to my YouTube channel so that I can create more such helpful contents like this. Hope to see you in my next videos. Till then, goodbye.